Hello, this is Jim with We Develop Electric Products. This is our seventh project with the Arduino for the beginner. Uh, and in the description below, you'll see links to all the previous videos, the previous six. And you can just click on those and watch those 6 videos. Uh, Also in the description, there's items that you can buy, the Arduino Uno, where you can get that. These breadboards and the components and everything else, where you can get those. Those are all in the description. The code that we're going to be using today, the script, will also be in the description. So you can just get that script right here. This is the hookup we're going to have for today's project. We're going to have 2 LEDs and a push button and 3 resistors, and then our Arduino Uno. We're going to have the push button connected to an input on the digital side, and it's going to be pin 8, and we're going to declare that as being an input. And then we're going to have 2 pulse width modulated capable pins going to the 2 LEDs. We're going to modulate those pulse widths to get the LED to change in intensity depending on what the push button is doing. So we've got one of those pin 5 connected to our LED 2 and going through a pole or a current limiting resistor, and that current limiting resistor is just 220 ohms. And then we've got pin 3, another pulse width capable pin, going to a current limiting resistor and going to our LED 1. And then the cathode of that LED, both those LEDs, are tied to ground. And then our push button, we have 5 volts going to one side of the push button, and then a pull down resistor and a wire going to our input, pin 8 of the Arduino Uno, to the other side of the switch. So the pull down resistor just has to be a value of somewhere around 10K to say 12.5 to 15K, and that'll be plenty sufficient. We'll go into calculating pull up and pull down resistors in another video. But right now, just use a 10K to 15K, and you'll be fine. And what this program is going to do, I'll show you in the code. Up here in the description of the code, it says we're going to use 3 digital ports. One will be to read a push button state. The other 2 will be pulse width modulated pins as outputs to light 2 separate LEDs. When the push button is pushed the first time, LED 1 will light at a low intensity and LED 2 will remain off. The second time the push button is pushed, LED 1 will go to full intensity, LED 2 will light at a low intensity. Third time the push button is pushed, LED 1 will go out, LED 2 will go to full intensity. And then the fourth time the push button is pushed, LED 1 will go to a low intensity, LED 2 will go out. And then we just keep repeating that process over and over again. We're going to be learning a couple new things this time around. When you're using push buttons, you have to what's called debounce the push button, or any kind of button. When you push a button, it can be either high or low and kind of varying between those 2 states or bouncing between those 2 states for a period of time. So we're going to have a debounce delay time before we actually say it is a high or it is a low of 50, and that's milliseconds. So we're going to assign an unsigned long. Now an unsigned long we're going to use because we're going to be using the internal clock of the Arduino. And when you use a clock, you're going to want to use an unsigned long, because if you sign it as an integer, it won't be too long down the pike before that integer overflows. And But if you use an unsigned long, I think that'll last for like 50 days, timing the number of milliseconds. So we've got two unsigned long here's. We've got two variables we assign, which is the last debounce time. We're going to set that equal to 0, and the debounce delay is equal to 50. And those are both unsigned longs because they're both going to be dealing with a clock. Now, if you want to look where we got this, if you go into Files and the Examples and go to Digital, there's one here called Debounce. That's basically what we're using. It's the Debounce circuit that's been supplied by Arduino. So they've got a couple different variable names, but it's doing the same thing. They're setting up button pin variable to be pin 2 on theirs. We've got that as pin 8. LED pin as 13. They're just turning on and off an LED in their example. We're going to be doing a little bit different, but the series here of how you debounce is going to be the same as we're using. So going back to the program, we've got some other defined here. An integer, constant integer. It never changes, which is the push button, and that's our pin 8. So that sets pin 8 as a variable called push button, but it's a constant. It never changes. And then we are designing a constant integer LED 1 on pin 3 of the Arduino Uno, and a constant integer LED 2 to pin 5. And then we've got a couple of other integers, push button state, to keep track of the state of the push button, whether it's high or low, and an integer which we're saying is last push button state, and we're going to assign that initially as low. So when you first go through the program, that last push button state will always be low. And then we've got a count to count how many times we've been through this process, and we're going to start that out at 0. And then we've got another integer, which is a button state, just to keep track of that button state, and we're going to assign that as a low to begin with as well. So then we just start out in our setup, and we assign pins to inputs or outputs. And so we got pin mode for our push button, which is pin 8, and we're going to assign that as an input. And we got pin mode LED 1, which is pin 3, and we're going to assign that as an output. And LED 2 pin mode, and we're going to assign that as an output. That's our pin 5 on the Arduino. And then we're going to initialize with a digital write to LED 1, a low value, and the digital write to LED 2 as a low value. And I had this serial begin 9600 in here for debugging purposes, so we could print out the values of these variables during debug. But I'm not using that anymore. I got rid of that. So we could take that out of the program if we wanted to, but we'll just leave it in there for right now. But we were using the serial monitor to keep track or to be able to view what these variables were while we were debugging this program. So now we go down into our loop. First we assign an integer push button state, and we do a digital read of the push button to see whether it's high or low. And then we check to see whether we just pushed the push button, and that's what we were doing there. And then come down here and we do an if statement. Now, we've never dealt with if statements before, but an if statement is making a decision. So if our push button state, and this is an operator that means not equal to. So if the push button state is not equal to the last button state, so the last button state up here we assigned initially as a low. So if it says if the push button state is not equal to the last push button state, then we're going to do something. And what we're going to do, if it's not equal to, we're going to do whatever's between these two brackets. and it says we're going to make the last bounce time equal to millisec, M-I-L-I-S, and what that's dealing with is the internal clock is counting the number of milliseconds. So we're going to make that last bounce time equal to whatever the clock says at the millisecond point. And if it's not, if it is equal to, in other words, if the push button state is equal to the last bounce state, then we go through this whole process and we drop down to this next one, which sets the millisecond internal clock minus the last bounce time and asking if it's greater than the debounce delay. So it makes another decision. It goes down here. If it is greater than the bounce delay, then it does what's in here, and it comes out with a high. So that's kind of the debounce circuit, and you have to kind of spend a little time studying this. Like I said, this program, this script will be in the description below. So you can look in the description below, and you can get this circuit or this script, and you can study it a little bit. It can be kind of confusing to start with, but I think you'll get the idea. And then we come down here, and if the push button state is a high after the debounce, if it's a high, we're going to set our count equal to count plus 1. We started out with a count up here of 0, and on our first push button, and we decide that it is high, we're going to increment that to a 1. And then we're going to drop down here to a series of if statements. And we're going to say if the count is equal to 1, then we're going to do an analog write to LED 1, and we're going to set it equal to 5. And we just, that's going to output a pulse width modulated signal of value 5. And we're just going to, it came up with that value empirically by experimentation to see that we could visually see that was a dim LED. And then we're also going to do an analog write of LED 2 of 0. So that's going to be a count of 1. That's going to be the first time through this loop. If it's count 1, it's going to ignore this down here. Count 2, count 3, and it's going to come down here, and it's going to say is count equal to, and it's got double equal signs because it's doing a comparison. Is count equal to a 3? It says no, so it comes down here. It makes our last button state equal to the push button state. So it makes it a high. And then it jumps right back up to the full loop again and goes down again. Second time through, when we've debounced and it comes up to high, this count is going to be equal to 2. So it comes down here. It bypasses number 1 here because count's not equal to 1. It comes down and says, okay, the count's equal to 2. We're going to do what's between these two brackets. It's going to do an analog write to LED 1 of 255, which that's full intensity, and it's going to do an analog write to LED 2 of the dim value of 5. So it's going to go from a off on LED 2 to a dim on LED 2, and from a dim on LED 1 to a full value on LED 2. And then the third time we go through this loop and the push button is high after debounce, the count is incremented to 3, and we go down here and we bypass these two if statements, and we go to count is equal to 3, and we do an LED write of turning off the LED 1 and going to full on with LED 2. And then we go down here and it says, okay, is it equal to 3? It says yes, so we set this count back to 0 again, and then we go back all through this whole thing all over again. So that's how we get this to go, and we're going through a debounce circuit on this push button switch, and then we're going through if statements to determine what the LED states are going to be, whether they're going to be dim or high, and keeping track of that count to figure that out. So that's how we come up with the program. And like I said, during debugging, and I had some debugging to do. I just set this serial begin like we did back in project, I believe it was 2, where we could view our tools in the serial monitor, and we could print out then some of these variables and see what's actually happening in our program. And so that's our project number 7. So thank you very much. So now that we've got all the code built, everything else, all you have to do is go up here like we always do and hit the arrow where it says upload and upload it. And it says compiling sketch, and we're compiling, and it's uploading, and it's done uploading, and it says no errors down here. So we've finished the upload, and we got everything, and we'll see how it works. Okay, so now we've downloaded the program, and if I push the button, first LED goes on dim, then bright and dim for the second LED, bright for the second LED, and off for the first, and it just repeats over and over again, just like we described it would. So that's how the code that we get this to go dim, bright, off. So if you like this video, hit the like button and subscribe to my video. I appreciate it. And have a good day and enjoy working with the Arduino.